So let's continue. Here the conversion is ethane to propanamine. Fine. So I was telling you that whenever you want cyanide group to be introduced, because you know cyanide is required as the chain is increased by one carbon. So you always need have a haloalkane for that purpose. Fine. So you can change this alkane into haloalkane using H nu, that is light of a suitable frequency, or you can heat also. Simply by free radical substitution reaction you will get chloroethane first, and further you can prepare cyanide from them, that is by using alcoholic potassium cyanide solution you can substitute Cl with cyanide group. Fine. So once you get cyanide group, now you take up their reduction and you see triple bond will change to single bond and hydrogen gets added. So you will get this compound. It's a primary amine and it is now chain is increased by one carbon, so it is propanamine. Fine. So like that you can have conversions. So in conversions you should take care that what is the change in the carbon atom in the chain of the two compounds which are asked in conversions. Fine. So this is one example. So next I will take up one more example of aromatic compounds. Let's do one conversion. Benzene to benzyl amine. Fine. Now this case you see that one carbon is increased, right? So we definitely need here one cyanide group attached to the benzene ring. Now let's see, up to the knowledge which we have studied, can we have this conversion by the same route as we have done in the previous case? We have to reach from benzene up to this stage. Fine. So if you see conversion, sometime you have to come back just to understand how to reach to the desired compound. So if you want to reach here, you should have cyanide attached to the benzene ring like that. Fine. So for that we know we have to do reduction. But now the question arises, can we directly convert benzene into cyanobenzene? Fine. So usually students think that if CN group is required, then we can have halogen here. Fine. So like that. And what they do, they know that how to convert benzene into chlorobenzene, that is using chlorine in the presence of anhydrous aluminium chloride or ferric chloride. So this is how students want to convert it, right? But the thing is, usually students, they convert like Cl to chain into CN. They usually, as we have done in the previous case, they use KCN, right? But remember, alcoholic KCN, we know this is a nucleophilic substitution reaction, and I have already told you nucleophilic substitution reaction do not take place in aryl, in case of aryl halides, because this bond is a very strong partial double bond. Under normal conditions this reaction do not take place, right? So whenever you are doing such conversion, so this step is a wrong step. Fine. This is a correct step, up to this is correct, but you cannot change Cl into Cn directly in case when it is attached to benzene ring. Fine. So this conversion can be done only through diazonium salts, which we will do later on. So I just wanted to tell you, because this conversion is just like the previous conversion I have done for aliphatic, but in this conversion please don't make such steps because it's not possible. There will be no marks will be given to you for this. Fine. Okay. Now using isocyanides, we can also prepare amines, but secondary amines. We have, this is structure of isocyanides, right? So under same condition, if you use lithium aluminium hydride, suppose as a reducing agent, then here also, if the pi bonds are removed, you are left with this situation. Hydrogens will be given as this is a reducing agent. So nitrogen require only one hydrogen to form 3 bonds and carbon requires 3. So you see here 2 R groups are attached here, so it's a secondary amine. For example, you have this compound ethyl isocyanide. Under same condition, it will give you this compound. At the end you will always get CH3. Fine. So this is simply N-methyl ethanamine. Fine. And we know this is a secondary amine. Fine. So this is how by using cyanides we will prepare primary amines, and by using isocyanide you can reach up to secondary amines. Fine. So this is one method of preparation of amines by cyanides and by isocyanides. Now we'll start with the fourth method of preparation, that is reduction of amides, acid amides. Fine. In general represented by this way. Fine. So acid amides using lithium aluminum hydride as a reducing agent here. So we know removal of oxygen will take place. Here hydrogen will be used to remove oxygen. That means one of the byproduct will be water. Fine. Now if the oxygen is removed from the carbon along with the bonds we have here, this situation. Fine. So carbon, required number of hydrogen will be given by lithium aluminum hydride, that is CH2. Right? So in total if we see 2 hydrogen here and 2 hydrogen here, that means in total 4 nascent hydrogen will be given.